Hello students, welcome to the class once again. I know you must be practicing questions on physics. I know you'll be doing good with all the questions that you are practicing. Now, before starting today's class, I'll just recall you what we have done in the previous class. We learned about normal force, tension force, we practiced problems. We saw when the blocks were attached through a string and the strings were passing through a pulley and how to solve such kind of questions. I told you how to relate the tension on two parts of the pulleys and how to relate the acceleration of the blocks that was arranged, that was associated, that was joined with the help of a string, and the string was passing on a pulley. Now in today's class what we are going to do, we are going to further extend the understanding of the chapter, and let me teach you a very new thing, that is pseudo force. Although it is not something new kind of force which I have written here, this is something which we are applying, and this force, let me tell you one thing, this force is an actually external force. But we are going to apply on our own an imaginary force. Let us see how we are going to apply it. Before understanding the concept of pseudo force, let me tell you two kinds of frames. Those are the reference for the reference frame. Two kinds of reference frame. Those are the inertial and non-inertial reference frames. So first of all, before starting the actual part of the class, the pseudo force, let's understand reference frames. Now see, reference frame can be of two kinds. In the earlier class, if you have watched the video, already I have discussed about reference frames, and in this class what we are going to do, we are going to see whenever we are going to apply the forces, whenever we are going to apply Newton's law of motion, when we are going to write the force equation, we will see how we can apply Newton's law when we are studying the object in some non-inertial reference frame. So I am using a term non-inertial and inertial. What are these frames? Inertial frame and non-inertial frame. Non-inertial frame. Now, what are these frames and why are we studying this? First of all, let me tell you what are inertial frames. A frame which has got no acceleration. If you're studying the object under consideration, if you're studying the acceleration or motion of object from a frame which is not having some acceleration, that frame is known as inertial frame of reference or inertial reference frame. So this frame, it doesn't have any acceleration. We are considering that it has got no acceleration, and we are going to mention all the no acceleration. Okay, so which kind of frames you can think of reference frame, inertial reference frame? Either the frame is at rest or the frame is moving with a fixed speed. Such kind of reference frame will be inertial reference frame. Sometimes we have to apply Newton's law of motion. We have to apply the forces while we are studying the object being in an accelerated frame. If a frame accelerates with respect to an inertial frame, such kind of frame is called non-inertial reference frame. In this, what happens, the reference frame has some acceleration. It has acceleration with respect to some reference frame. It has acceleration with respect to inertial reference frame, with respect to inertial frame. Now, how to differentiate the two? As I told you, it has got no acceleration. When I say no acceleration, by that I mean either it should move first with a fixed speed or it should have no motion. So no motion, that means it should be at rest. The frame should be at rest, or it should move with a fixed speed, or it should move with constant velocity, that means no acceleration. Move with constant velocity, that means no acceleration should be there. Non-inertial frames, as I told, it has acceleration with respect to inertial frame. That means if we are studying the motion of an object from a reference frame which already has an acceleration with respect to some inertial frame, such kind of frame will be non-inertial frame. Now, what idea can you make out from these two frames? Suppose I am on earth, I am on ground, and let's say this is earth, this is ground, and let's say I am on earth, or anyone any boy we can take as on earth. Now suppose if I observe a truck or any van or bus moving, if I observe a bus moving, let's say I'm observing two boys, and let's say this bus is accelerating with some acceleration. Let us say it is having some acceleration, it is moving. So what I will observe, this is observer A, B and C. If I observe from here, I'll be saying that since this bus has an acceleration, that means these two boys B and C are also having some acceleration. So that means a force should be acting on this boy, mass of B into acceleration, mass of C into acceleration. Now let us say that now B is observing C. Being in the reference frame of B, being in the reference frame of bus, B observes C. So when he observes C, he will say that C is at rest with respect to him. C is at rest. So that means no force should act on the body C. No force should act on C because he is observing C is at rest with respect to him. But originally we know that, as you have observed from the earth, we have known that a force is acting on C, and that is mass of C into acceleration of the bus. That force is acting on C. But if B observes C, he will say that his net force on C should be 0. Or to apply Newton's law, to understand what we are going to do to make net force on this to be 0, we are going to apply a force on C as mass of C into acceleration of bus as ma. So whenever what this force we have to apply externally on this boy C, so that we can apply Newton's second law while we are studying the object being in the reference frame of bus. We have observed that since bus is accelerating, so this C appears to be at rest. What you do? Apply an external force in the opposite direction of acceleration on the C, so that you can equate the equations. Now you will get that a force acting towards right, that is the frictional force or any force that is actually responsible for it to drive towards right hand side. So what we got from pseudo force. How to apply pseudo force? Let's write down those points with this example. Now before proceeding, let's come here once again. This force that I have applied, this force is only known as pseudo force. And now we'll start understanding the concept of pseudo force, and we have already understood about the reference frame. The bus frame was a non-inertial reference frame and the earth reference frame was inertial reference frame, as just now I have told you. Now let's come to the part that is the pseudo force. Pseudo force, first of all, this is an external force. It acts externally to the object, so that's why we will take this and not an internal force. This is an external force. It is an external force. First point. Second thing, when it is applied, it is only applied on an object when we are studying the motion of object from an accelerated frame or from a non-inertial frame. It is applied on an object. It is applied on an object when we study the forces on an object, when we study the forces on an object, forces or motion also we can say, even that also will not be a wrong term, it will be also right. When we study forces on an object from a non-inertial reference frame. Don't get worried about the term inertial and non-inertial. That is nothing, that should not confuse you all by the term inertial, non-inertial. You can just think that non-inertial means already the reference frame has an acceleration with respect to the inertial reference frame, non-inertial reference frame. Now, in what direction you should apply the pseudo force on the object when you are studying the object from a non-inertial reference frame? So apply the force opposite to the acceleration of non-inertial reference frame. Apply the force opposite to the direction of acceleration of non-inertial reference frame. Apply the force opposite to the direction of non-inertial reference frame. Now, what should be the magnitude of the pseudo force? The magnitude that you have to apply, magnitude of pseudo force. Just now I have told you it should be equal to mass into acceleration. Acceleration that you have taken, that is the acceleration of the non-inertial reference frame. So, magnitude of pseudo force should be simply equal to mass of object into acceleration of non-inertial reference frame. Non-inertial hope that this is visible up to this distance. That's visible. I believe that you can mark as m into a. I'll just give a quick recap of what are the points that we need to consider. Pseudo force. First of all, remember the point when we have to apply pseudo force. Remember, the requirement only begins, it only gets initiated when we are studying the motion from a non-inertial reference frame. Now, from a non-inertial reference frame, I mean that the frame is accelerated. Pseudo force, first point, it is an external force you are going to apply. Second, it is applied on an object when we study the forces on an object from a non-inertial reference frame. So, when you are going to apply pseudo force, only when you are going to study the motion of object or forces acting on the object from a non-inertial reference frame. Third, apply the force opposite to the direction of non-inertial reference frame, opposite to the direction of acceleration. I have missed the term acceleration, opposite to the direction of acceleration of non-inertial reference frame. And fourth point, magnitude of pseudo force equal to mass into acceleration of non-inertial reference frame, that is the value of pseudo force. How to do such kind, how to apply and where to apply the concept of pseudo force, we will understand this with an example. Let us take this. Let's start with an example. We have an inclined plane. We have inclined plane, and let us say we have an object of mass m. Now, a force F is applied, okay, and we have to find out, let us say the angle of inclination is given as theta, this is m, this is capital M. Now, it has been asked what is the value of force F if mass of block whose mass is small m that is at rest on the inclined plane. So, it has been asked find F if block of mass m is at rest. So, find F if block of mass small m is at rest with respect to inclined wedge. I want you all to just take down, I will start the solution here. Okay, hope you have noted down the diagram of the question, and if you have not started the solution part, let's see how we are going to approach. You must be seeing the diagram. We are required to find out what the force we are applying on capital M, that is on the inclined plane, so that the small m doesn't move. Now, first of all, what we will do, we will make free body diagram. Free body diagram of M, you see, on it will be acting. Just of all, I will just like you all to take to the diagram here. On it, the forces that is acting. First of all, its weight that is acting in the downward direction. So, I am writing it as capital Mg. Now, you see on M, force due to pull of earth will be acting M downward. Now, a normal reaction will be acting due to the ground. Let us mark it as N1. Now, due to this block, capital M will exert a force on this block, and that will be the normal force. Let us mark it as N1. Now, similarly, M will also exert a force N1 in this direction. So, now we got all the forces, and on M we are having mg will be acting downward and its component mg sine theta will be acting here. Let's make the FBD of capital M here. FBD of capital M will be having, if I mark here capital M here, the forces acting are weight capital Mg, normal reaction by ground that is taken as N1, normal reaction, now again the contact force by the small block that is N1 here we have marked, and the force capital F, that was the external force that is acting here. Now if I take the FBD of small m, FBD of small m is here, you see N1 force, N1 contact force will act along this direction. This is the force M1 into G. Now how to solve this question and how to apply the contact force required, how to apply the pseudo force in this case will be, now you see, if we go on and apply the forces on small m by being on the wedge, on the reference frame of wedge, so we have to apply a pseudo force. So we have to see what is the acceleration of the combined reference frame that we are talking about, that is the reference frame of the wedge. So both are moving together with an acceleration a. That the value of that acceleration will be the acceleration a of system small m plus capital M will come out to be net force upon total mass. So acceleration a we can write as F upon m plus m. So both the object, both the inclined wedge and the small m will move with an acceleration a. Now you can see that to apply Newton's law of motion being on the reference frame of the wedge, we have to apply a pseudo force on this in the opposite direction just now I told. So apply a pseudo force m into a, and a is the F upon m plus m, just now we have done it. Now what I'm going to do, I'm going to draw a line. This is parallel to the plane of incline. This will be angle theta and this will be also angle theta, which you can easily identify. M1G component along the incline, you can check, it will come out to be M1G sine theta. Now MA is the force that is acting, that we have applied the pseudo force. I will write especially here, this is the pseudo force which we have applied on small m. Now MA component towards this line, it will come out to be MA component towards this line will be MA cos theta. Now since this block was not moving along the incline, so let us use Newton's second law, net force is equal to mass into acceleration. So equating forces along the incline for small m, equating forces along incline, see what we are going to obtain. We will be having M1G sine theta will be equal to MA cos theta. From here we are going to obtain A as, this will be also as M1, this will be also, and that was small m, I use the term M1, that don't take it as M1 because it's small m. Sometimes when we are regularly speaking we can get into that, sometimes we use M1, be cautious to make it as small m. A comes out to be, mm will cancel out, it will be g tan theta. Now earlier we have already identified the value of A as F upon small m plus capital M. So we will get A as F upon small m plus capital M is equal to g tan theta. From here F comes out to be m plus capital M g tan theta. This is the value of force that is required to be acting on the wedge, that was the inclined plane towards right hand side, so that the small m is not moving relative to the wedge. It's not having an acceleration along the incline. So I wish you can note down. I will start from here. So this was a simple question showing the application of pseudo force. So we understood that pseudo force applied only the case when we are studying the forces or the motion of object from any accelerated frame, that is the non-inertial reference frame. Let's go ahead and let's do one more question. This is a simple question, and this is an example. Suppose on a wedge, this is a wedge, let us say the wedge has an angle theta. Here we have another arrangement, okay, and here we have placed a weighing balance. This is actually a weighing balance which will actually record the weight. It's a weighing balance. It will record the weight of anyone. So let's say on this weighing balance, a man his mass is capital M, and let's say this is a mass of small m. Now it has been asked, find out if this wedge is under free fall. If this wedge is under free fall, find out the weight recorded by the weighing balance. Let's say this is the question. So we have to find out, find weight recorded by balance, or recorded by the weighing machine, recorded by weighing machine. This is what is the requirement by weighing machine. Now see here, this is under free fall, it's coming freely. So one thing is for sure, the acceleration will be g sin theta of this entire frame. So g sin theta, I am marking the acceleration with which it is coming down, because only the thing we can resolve g along this direction, that will come out to be g sin theta. That is quite easy and comfortable, you will be easily evaluating. Now the weight measured by the weighing balance is actually the normal reaction which it applies on the object. The normal reaction on this man, let's mark it as n. Hope that this is visible. Let's mark it as n. Now let's write down all the forces that is acting on this body of mass, the boy of mass m. So what we are going to do, we are going to study all the forces acting from the reference frame of this wedge, or let's say you have to stand here. You have to stand here, and now you have to check what are the forces acting on this man of mass m. So we are going to apply Newton's second law while being on a non-inertial frame. So for that I have told you, see, this is the man, the normal reaction we want to measure. What is normal reaction? And a force acting in the downward direction, that is the mg. Now since this is moving, so we have to apply a pseudo force on this mass m, such that this pseudo force will equal to mass into acceleration, that is g sin theta. Because I told you, apply the pseudo force as mass into acceleration opposite to the direction of motion of acceleration of reference inertial non-inertial reference frame. The first g sin theta, so apply here m into g sin theta in this way. Now you will be obtaining this angle. You can see that this will be theta. You can make out this will be theta. So automatically you can make out that this will be theta. We can make out this will be theta, this will be 90 degree, this will come out to be theta. Now we are interested to know, or you can think in this way, this will be theta. So let us equate the forces along the vertical direction. So equating the forces along vertical direction, see what we are going to obtain. Equating forces along vertical direction. You see here, n is acting in the upward direction, mg is acting in the downward direction, and the component of mg sin theta along the vertical, it will be mg sin theta into sin theta. So we will be having the resultant forces n plus mg sin theta multiplied by sin theta should be equal to mg in the downward direction. So what we are going to obtain n as mg 1 minus sine square theta, that is, this will come out to be n equals to mg cos square theta. This is the value of normal reaction, and this will be the only weight that is recorded by the weighing balance. Hope that is easy for you all to understand, and hope that you have understood how we have got this. Now I'm going to start a new question. Please take down here. I will start a new question. So this was an example again of a pseudo force case. Two simple examples to give you a proper understanding of the how to apply pseudo force, and it will be very much clear to you all that need not to worry about the pseudo force. You have to only apply it when the body on which you are going to apply it to the second law, that is you are going to study its motion from a non-inertial reference frame, and non-inertial reference frame is one which has some acceleration with respect to the inertial frame. Let's do one more example. We have been provided with an arrangement. It is saying, let's say we have a bigger block. Let's say its mass is capital M. It is on ground. We have a pulley. We have a block attached here. Its mass is M1, and we have a block attached here. Its mass is M2. It is given that a force, this is touching, this is in touch. It is given that a force is applied on this larger block, and that force is F, such that the acceleration of M1 is A1 downward, and the acceleration of overall M is A towards right. This has been provided. So we have been given with information. The informations are, first, shown is in the figure, the strings and pulley are light. So the first information is strings and pulley are light and frictionless. As per the requirement, I have told you all this meaning several times. Second thing, the system moves with an acceleration A towards right. System moves with an acceleration A towards right. Moves towards right with an acceleration A. Systems moves towards right with an acceleration A. This is the second statement that have been provided. Third, block M1 is coming down with acceleration A1. Block M1 is coming down with acceleration A1. This has been provided with the, so we have all these three information. This force is F is applied, it is also given. So we have to find out this force in all these respective variables, capital M, M1, M2, A1 and A. See how we are going to do to find out the value of force. Let us solve here. First of all, as I told you, first you have to decide the system. All three are moving. This is this is at rest on this block. It's not at rest. Actually, it's moving on this block because this is an acceleration A1. So this will be also having an acceleration A1. See here, we have to make FBD of each of the objects. First, FBD of capital M. See here, what are the forces acting on capital M? This is capital M that I am drawing. Its weight will be acting downward. That will be capital Mg. Its weight will be acting downward. That is the pull of the earth. And now you see this surface will provide a normal reaction upward. I am marking this normal reaction as capital N. So which we have to show here as N acting here. Now you see here, due to this weight, actually this block will apply a normal reaction on M2. M2 will apply a normal reaction on capital M. So what we can write, and it will apply its weight on capital M. So we can write one more thing as M2G, that is acting on capital M. So I am also writing M2G is acting in the downward direction on capital M. Now see here, we need to also consider the tension in the strings. Let us say the tension in the string is T everywhere. So this T will be here, this T will be here. Now T will be also acting in the upward direction here, and T will be also acting on this M2 in this direction as shown. Now see this pulley, we are applying the forces. This tension T is actually pulling this pulley downward, so this tension T will be acting in the downward direction on this block, so I will also mark tension T acting in the downward direction. Now also see, this tension T is acting towards left, so what we need to do, we need to apply this tension T towards left on this block. Force F is acting towards right, so I am marking force F acting towards right, and it has an overall acceleration of small a. So we have to show this has an acceleration a. See all the forces we have marked. One more thing, M1 is in contact with this, so let us take the normal reaction that this M applies on this block. Let's say this is as N1, so we have to also apply a force N1 as shown here. So many variables I have shown you, need not to worry, it will be very easy for you all to get all the required details. Don't worry about all this. First of all, see, I have marked all the forces. So equating forces along x-axis, so along x-axis if I write the forces, that is along the motion, so I will be having F minus T minus N1 is equal to capital M into A. This is equation number 1. F minus T minus N1, that will be equal to M into A. Now along y-axis, if I write the forces, that is Fy should be equal to 0, because there is no net force along y direction, should be 0 because there is no motion along the vertical direction. You can see capital N will come out to be equals to T plus mg plus m2g. We got this, and let us say this is equation number 2. We got this capital N equals to T plus mg plus m2g. Now after this, let us change the system. Let's make M2 as the system, M1 as the system. So FBD, because we are doing something new, so I am marking this as FBD of M1. So M1, if you draw, M1 will be something like this. You may draw in this way. M1, the forces acting to the normal reaction, and it will be same as N1, which we have marked here. So N1 will be acting towards right, and it is coming down with an acceleration of A1. Next, you see tension T is acting in the upward direction. Mark tension T acting in the upward direction, and you will be having M1g, its weight in the downward direction. So along vertical direction, you can see M1g minus T will be equal to M1 into A, and along horizontal direction you can write N1 equals to M1 into A, because this is also moving in the horizontal direction with an acceleration A. So for this, I am writing sigma Fx should be equal to its mass M1 into A, implies that N1 is equal to M1 into A. This is about the F direction force, and similarly for y direction, sigma Fy will be equal to M1 into A1 in the downward direction I am talking about. So M1g minus T should be equal to M1 into A1. There are a lot of equations. Let me write this as equation number 3, and let me write this as equation number 4. I want you all to note down till here. I will continue from here. Okay, what I am going to do, I am only going to rub this part, and the diagram I am going to keep as it is, and the equations are there, that is given to us. So just we are left with to write on the force equation for the block M2. So FBD of M2, if we make, see we are going to get M2. Now the force acting is tension towards right, and we will be having M2g in the downward direction, and we will be having normal reaction that already I have shown you, that already I have used as N1. I believe it will be N1, F minus T we have used, so this should not be N1, this should be N2. Let me take this as N2, and N2 will be equal to M2g, that we have seen. Now equating, now this is moving with an acceleration a1. Now see what I'm going to do. If I observe this block m2 from this wedge reference frame, the wedge is moving towards right with an acceleration a. So I have to apply a pseudo force m2 into a in the left hand side direction. So apply a force m2 into a in the left hand side direction. See what you're going to get. Applying the forces along x axis, we will be getting this as m2 into a1. So using this, we are getting t minus m2 into a is equal to m2 into a1, equation number 5, which we got. And one more along y direction, we can write sigma fy will be equal to 0. So m2 g is equal to n2, equation number 6. So many equations, do not get worried, don't get worried. We have nearly done all the part of the question. We are required to find the value of force F. Now see, you must be having the idea of, see, force you can get from here. If you can calculate the value of T somewhere, you can get the value of N1, you will get all the things. N1 is here, N1 is equal to M1 into A. So what we can do here, we can write N1 as M1 into A. We have to only eliminate T. Now you see, to eliminate T, first of all, you can get T as equal to M1G minus M1A1. So I am writing from equation number 4, from equation number 4, we can write T as, T should be equal to M1G minus M1A1. So M1G minus M1A1 will be equal to T. So we got the value of N1, that was M1 into A, and we got the value of T also. So substitute here, see in equation number 1. I'm going to rub this part. Now we are no more, we need all this. So substituting the value of T and N1, we are going to, from N1 from equation number 3, substituting N1 from equation number 3, substituting N1 from 3 and value of T in equation number 1, see what we are going to get. We are going to get F minus T, and T is M1G minus M1A, so this will come out to be minus M1G plus M1A1, and we have minus N1. So N1 value already we know that it is equal to minus M1 into A, should be equal to capital M into A. So we got this. Finally we got this. We want to evaluate the value of force which was required. So force comes out to be M1G minus M1A1. So M1 we can take common, M1 G minus A1 plus A plus capital M into A, or what you can do, you can write in this way, M1 G minus A1 plus A M plus, you can even write in this way also, even the earlier way also is right, you can even write in this way also, that's also, we can take M1A here, and outside we can write here plus MA, so we can take M plus M1. So even we have this value also. So this is the force that is required. Now suppose if the question is asked, also find out the acceleration of the blocks that were shown here in terms of force. So what you can do, if you know any one value, you can relate, you can see all these equations, you can make certain terms, we can make some acceleration as a subject, and you can get the required value of acceleration in terms of F and in terms of other masses. This was one good question which we have done here, and I want that you all practice this question. It's a very good question, and practice more from the textbook you have, so that the understanding will be more better with you, and you will see that Newton's laws of motion is quite easy to do. I request you to do some standard book questions that you have with you, so that it will become handy and easy for you all to do. Now one more advice for you all in today's class. Do revise what we have done. See where you can apply the concept of pseudo force, so that the question becomes easy. Once again, I'll give you a quick recap of today's class. First, we studied about reference frame, inertial and non-inertial reference frame. Inertial frames are those in which is not accelerating or whose speed is constant or it is at rest. Such frames are inertial frames. Non-inertial reference frames are those when you're going to apply Newton's second law in some reference frame which is having some acceleration, with respect to some inertial reference frame. Earth is generally we take as the inertial reference frame. Rest all other frames which are accelerating with respect to Earth are taken as non-inertial reference frame. Second, we talked about pseudo force. When you are going to study the motion of object or the forces acting on the object, being on a non-inertial reference frame, apply a pseudo force in the opposite direction in which the direction of acceleration of non-inertial frame was present. So just apply an acceleration opposite to the direction of non-inertial reference frame. You will be seeing that it's very easy for you all to use the concept of Newton's second law. Do practice question, it will be very easy for you all to do. So I am thanking you all for listening to me so patiently. Do practice questions, take good care of yourself. All the very best to you all. This is Abhinav signing off. Thank you.